Well, good morning, everyone. My name is Zinedine Zeshro. Welcome back to my channel. And today I'm going to be making a presentation about Oracle database architecture. This is my college task for my midterm, so just enjoy. First, we'll start with an overview of what is an Oracle database. So Oracle database is a relational database management system, or RDBMS for short, developed by the, not infamous, the very famous Oracle Corporation, headquartered in San Francisco. Its architecture is designed to provide scalability, reliability, and performance for managing and storing large volumes of data. Here is an image of the most common architecture for an Oracle database. We can see that there's a database server, which is the one that's going to be holding the database instance or the database itself, in which it will have several parts inside. So there are the System Global Area, SGA, which we will be discussing later on, Program Global Areas or PGAs, and background processes. These are the three main parts inside a database instance. But other than that, there's also client application on the outside, which will be linked through a listener, which we will also be discussing after this, and obviously the database itself below. First of all, let's start with the listener, which is arguably perhaps one of the most important parts of an Oracle database. So there are three main points for listeners. First of all, is listener as a database listener is the database listener process. The listener is a separate process running on the database server that listens for incoming connection requests from client applications. So listener is the one that connects the client through their client applications to the database itself. It is also acts as a mediator for the Oracle server, as it acts as a mediator between client applications and the Oracle database server, routing the request to the appropriate Oracle database instance based on the service name or SID or system identifier. Again, just like the database listener process. So so inside a database server, there could be a bunch of database instances where the listener will be the one that will be mediating the communication process between the client application and also the database instances, and it will basically it will act as a router for the server. And then listener setup. The listener configuration includes parameters such as protocol addresses, TCP, IP, and IPC, authentication methods, and service handlers. This is the diagram of how a listener would work in a database server and in an Oracle database server. So as you can see in the left side of the screen, you can see the client application, and then the connect packet, which is the one that the client will be sending, which will be taken by the listener, and then the listener will act as the mediator, just like how we previously discussed, and it will connect the connect packet from the client application to the database instance. Then let's talk about the database instance itself. So here is a graph of the database instance. So inside the database instance, there are three main parts, which are very important. First of all is the system global area, the program global area, and background processes. All three of which we will be discussing after this. But what is a database instance itself? A database instance is the combination of memory structures and background processes that manage the Oracle database. That is the basic understanding of what a database instance is. And just like what I previously mentioned, there are three main parts of the database instance. First of all is the system global area, or usually called as the SGA. The SGA is a shared memory region that stores data and control information for an Oracle instance. And then there's also the PGA, which is a memory region allocated for each server processes or background processes that connects to the Oracle instance. And lastly is the background processes, which are system processes that perform various tasks necessary for the functioning of the Oracle database instance. First, let's start with the System Global Area, or SGA. So SGA has a main duty of holding the data and controlling information for the Oracle database instance. And it usually is divided into 4 components, with one of them being quite optional. The first one is buffer cache. The buffer cache holds copies of data blocks, but blocks read from the data files. It helps to reduce disk input and output by setting frequently access data in the memory. And then we got the shared pool, which contains shared memory areas such as the library cache, which stores the SQL, NPL, SQL code, and the data dictionary cache, which stores information about the database objects itself. And then the redo lock buffer. This buffer temporarily holds redo entries before they are written to the redo log files. And the redo entries are changes made to the databases and are used for recovery purposes. So this is if there are changes or there are issues, the database admin could use the redo lock buffer to check out the log, to log if there are any changes, and if they need to recover, they use this one. And then this is optional, but there's sometimes, so it means there sometimes is one, there sometimes isn't one, which is large pool. So it is used for large memory allocations such as backup and restore operations, parallel execution buffers, and IO server processes. Next is the PGA, or Program Global Area. So its main duty is different to SGA, in which PGA contains data and control information specific to each user session or process. And it is divided mainly into two components, which is the first one, session memory, which includes variables and data structures specific to each user session, such as sort areas for sorting data, session variables, and session-specific context information. And then we got private SQL areas, which contains information about SQL statements being executed by a session, such as parse query plans, bind variables, and runtime execution context. Lastly, we got background processes. Again, this is disclaimer, this is not all of them, but these are 4 which are usually most of the time required for a single database instance. There are also those that are additional, but these are the 4 that are very common to exist inside a database instance. First of all, the first one is PMON, or process monitor. PMON is responsible for process cleanup and process recovery. It cleans up resources associated with terminated sessions and performs instance recovery during database startups. And then we got SMON, system monitor, which performs instance recovery and cleanup tasks during database startup and shutdown. It also coalesces contiguous free space in the database after deletes or updates. DBWN, or database writer modifies data blocks from the buffer cache to the data files. It helps ensure that changes made to the database are persisted to disk. LGWR, or log writer, writes redo log entries from the redo log buffer to the redo log files. It ensures that changes made to the database are safely recorded in the redo log files for recovery purposes. Next is one of the main features of an Oracle database, which is multi-tenant architecture. So we can see in the diagram in the left side. So multi-tenant architecture in basic terms means that inside a single database architecture, database server, there can be multiple databases, which are all of them are unique individually, but they all work with the same resources and can be accessible through a single container. So this is let me read out this part, which is the explanation. The multi-tenant architecture allows you to manage multiple pluggable databases, or usually called PDBs, within a single container database, or usually called CDB. This architecture is particularly useful for database consolidation. This enables you to efficiently use hardware resources while maintaining isolation between different databases. First of all, let's talk about the container database. So container database, or usually called a CDB, acts as the main repository for metadata and common data. It consists of the root container and optionally one or more user-defined pluggable databases, which is the one that can be a lot. We will be discussing about PDBs after this. The root container contains the common data dictionary and provides services shared by all PDBs. It hosts system-related metadata and provides common services such as the listener, background processes, and SGA components. And then we go to the PDBs, which are pluggable database, which are fully functional separate database that can be plugged into a CDB. So CDB, as its name says, it is a container, and the database itself that we can put inside the container are the PDBs. So each PDB has its own data files, table spaces, users, and application objects, making it appear as a standalone database to applications and users. PDBs also share common resources from the CDB, such as background processes, memory structure, and obviously the listener. They have their own set of PGA and session-related resources, providing isolation between PDBs. And that is all for my video today. Hope you enjoy it, and hopefully this allows you to get a bit of an understanding of how an Oracle database architecture looks like. Well, thank you for listening and wish you a good day. Bye-bye.